Good morning. Welcome to How to Get the Most Out of Your Building Automation System with Service, presented by HVAC Engineering Magazine and sponsored by Johnson Controls. I'm Scott Arnold, Executive Editor of HVAC Engineering. Before we meet our presenters, allow me to explain how you can get the most out of this event. First, if you're experiencing technical difficulties, please refresh your webinar console by pressing the F5 key on your keyboard. If you still need assistance, please click the yellow help icon below the slides. At any time during the presentation, you may submit questions to the presenters. To do so, simply type in the window on the side of your screen and click Submit. Our presenters will answer as many of your questions as possible during the question and answer session following the presentation. In the coming days, certificates of attendance will be emailed to individuals in attendance for the entirety of the event. Lastly, this webinar is being recorded and will be available at hpac.com for 1 year. You'll be notified by email when the recording is available. Okay, we have a full and varied agenda for today's webinar with more than 550 people registered to join us. Kicking things off, we have a panel discussion led by Renee Collins, Vice President of Owner Sales for Johnson Controls Systems and Services North America. Renee, who has a bachelor's degree in applied engineering from Michigan State University, began her career with Johnson Controls in 1981. Since that time, she has held many positions from sales to sales management to region general management within the Building Efficiency Group. In her current role, she develops service strategies to achieve desired business outcomes for Johnson Controls customers. Joining Renee on the panel will be Buddy Saucier, Vice President of Service, Security, and Fire Operations for Johnson Controls Systems and Services North America, and James Nanini, Vice President of Building-Wide Systems Integration for Johnson Controls Systems and Services North America. Buddy has more than 30 years of experience in the HVAC service industry. He has led P&L and functional business teams and is a recognized champion for project management and change management. James joined Johnson Controls in 2005, bringing 25 years of information technology services and software leadership experience in the areas of sales, sales engineering, marketing, operations, and general management. He leads a team focused on leveraging technology convergence throughout the building enterprise during a construction event, reducing first costs and building life cycle costs, as well as ensuring integration performance to deliver customers' defined outcomes. His team provides solutions that optimize energy, comfort, security, and productivity. Later in the webinar, we will be hearing from another member of the Johnson Controls Systems and Services North America team, Juliet Pagliaro-Herman, Director of Service Product Management. Previously, Juliet served as the Program Manager for Energy and Sustainability for Johnson Controls globally, and prior to that worked for General Electric Healthcare in various roles in global service technology. Together, our presenters from Johnson Controls Systems and Services North America have more than 80 years of industry experience. They are pleased to be joined by Dr. Srinivas Katipamula, Staff Scientist for Pacific Northwest National Laboratory. Dr. Katipamula has extensive technical experience in the evaluation of advanced design concepts for heating, ventilation, and air conditioning systems, demand response techniques for commercial and residential buildings, development of automated fault detection and diagnostic techniques, building and energy system simulation, analysis and evaluation of new energy efficient technologies, and development and use of analytical modeling techniques. Recently, he led a team that demonstrated price-based controls in commercial and industrial sites. Before we begin the panel discussion, we have a question for those of you in our audience. What trend has most impacted how you use your BAS? The Internet of Things, cybersecurity, workforce attrition, or energy initiatives? We'll give you about 30 seconds to answer, and then we'll review the results. Okay, it looks like winning by a landslide was energy initiatives, followed by Internet of Things, and closely behind that, workforce attrition, and then cybersecurity. All right, thank you for participating. Now I'd like to hand things over to Renee, who will lead the panel discussion. Renee?
Thanks, Scott. Hey, good morning, everyone. We really appreciate everyone joining this morning. To kick things off, as Scott said, I've invited a few of my colleagues from Johnson Controls to join in a short discussion to talk about your poll response, react to your poll response, and then also provide some insight into social, economic, and technology trends that we see are impacting how building automation systems are seen and used within the enterprise. And I just want to add that Chris Lane, one of our senior product managers from Johnson Controls, is also joining our panel. So thanks, Chris, for joining. So, you know, it was interesting to me, the audience says the number one trend that's impacting the way they use the building automation system is the need for energy efficiency. And actually, Dr. Katipamula will talk about some research that he's conducted in terms of what some of the challenges are in running efficient and productive facilities. But maybe, Buddy, I could get your point of view on that first. You know, what are some of the challenges that you're seeing in, you know, maintaining a well-tuned building automation system?
I'd say, Renee, some of the things was probably the third item up here. Most item was the workforce attrition, and what we're finding a lot of customers are dealing with is aging workforce. You've got your baby boomers that are leaving organizations. You've got your Gen X, Gen Y, your millennials that are coming in. And typically what we're finding is there's been a lot of emphasis over the years placed on four-year degrees. So there's not been a lot of emphasis on apprenticeships any longer, or folks going into, or individuals going into skilled trades. So there's a shortage out there of skilled trades, whether it's control technicians, operators, skilled mechanical workers, and it's creating a lot of challenges, not only for customers, but for OEM providers like ourselves.
Right, so you think about now, you know, more and more you need the mix of skills of understanding the technology, but also understanding HVAC systems in order to run a well-tuned building, and that combination is probably harder to find.
Absolutely, Renee. Absolutely.
Yeah. So, you know, and we talk about technology and how much that's changing, and the buzz, you know, of course, is the Internet of Things. But I guess, you know, can we talk through what that means to, when it comes to building technology and operations, Jim?
Absolutely, Renee. I believe that the Internet of Things, or IoT, provides us an excellent opportunity to mine greater data. So if you look at it from the foundational layer, it's all about connecting systems that haven't been connected before. It's about sharing data with those systems that, once again, that historically have not been connected, and then taking that data and optimizing that and turning that into actions. Those are operational actions. Those might even be machine-to-machine type interactions from the Internet of Things. So a tremendous opportunity to get visibility to the enterprise level of information to run the building more efficiently.
Good. So, I mean, you know, more technology, and we have more data available, but I suppose that also it becomes an interesting challenge in terms of how the data is used today, and maybe how it's used differently today than in the past. Any thoughts on that? More data, more information. What does that mean to the building operator? And Buddy, you want to?
I'd say sometimes it can be confusing when you have too much data.
Yeah.
But more and more than ever, you know, you think about how people buy and purchase. A lot of people buy on emotion, but they really solidify and back that up with data. And we're finding that more and more than ever. As Jim mentioned, you know, the ability to share data across different systems are more important than ever, and we can thank the advancements in technology from aerospace and healthcare.
Right.
Those advancements are finally trickling in now for years into the HVAC and control and BAS industry. But the accuracy of the data is so important, because you can make those impulse decisions that could cost you either replacing an air handler if nothing was really wrong with it, because you may have had sensors that are out of calibration, things of that nature. We rely on the data more and more, and we find that customers are relying on
it more and more. Yeah.
Yeah.
You know, within the last 2 years, and this Johnson Controls team knows this, but we've interviewed more than 1,500 building owners and managers, And, there's probably 3 common themes that have emerged. They told us that they would like to reduce costs, so make their buildings more efficient, reduce risk, so that kind of points to what Buddy was talking about, right? Using data to help manage risk or risk avoidance. And then, they've also said, hey, help me make my building simpler, to operate across the building life cycle. And Chris, can you talk more about what you've heard about expectations of a building automation system and ease of use?
Sure. As Buddy mentioned, we're seeing kind of a shift in the workforce that facility management staffs have to work with. So we're seeing a reduction in staffs. They're asking their staff to do more with less people, and with the advent of the Internet of Things, there's more data to kind of look through. We're also seeing a change in expectations from BAS users based on their experiences with like Google search, using social media applications, shopping online, and then using their phone for doing everything more than just making phone calls, which is probably the least used application. They're using their phones to do all sorts of things that hadn't been done before with that powerful device in their hands, a very mobile computing platform. So from a building automation system provider, we're seeing a higher expectation from users on being able to more quickly find, learn, and take action on their building automation system functions. So with the advent of Internet of Things and various different energy management applications that are out there, we want to provide our users with data that they can make sense of and then learn more about it and then quickly take action so that they can feel confident that what they're doing is actually making a difference in a positive fashion.
Good. One thing that we didn't touch on as a group, and actually the poll response was low in this area, is cybersecurity attacks. It's an interesting topic. We read a lot about it in the paper, but we're finding that more and more, our customers are saying, hey, I need to protect my building automation system from cyber attacks. How do I do that? I guess, Chris, can you just talk about, how this impacts our product development and maybe even, the maintenance of building automation systems?
Sure, yeah. There was just one recently yesterday about the Jeep Uconnect system being hacked and by a benevolent hacker, and they were able to take over the steering, the brakes, the engine, basically full command of the car. That just highlights some of the things that can be done when there are vulnerabilities in any kind of system. From a product development standpoint, on a building automation system, we realize that a building automation system is not a standalone entity. It has tentacles that reaches out and interconnects with different third-party devices. Our software is typically hosted on the customer's server or PC platforms, so there's that interaction that we need to accommodate. And also, users want to be able to access their building automation system from wherever, and oftentimes when they're outside of the building, so they don't have the physical protection of being within the building. We have to accommodate that. So there's different attributes of a building automation system that kind of need to be considered, especially with the advent of Internet of Things and everything being interconnected and things changing. So again, a building automation system is not a static entity. It's dynamic. It interfaces with components that are also changing. So it's important to keep your building automation system updated, its software upgraded, so that you're at the current level, so that new security vulnerabilities that are exploited either by benevolent or non-benevolent hackers are patched and fixed and closed, so that you can prevent unwanted access to your systems and prevent damage that can occur by unauthorized access.
Perfect. Hey, thanks, team. So we've talked about the Internet of Things, cybersecurity, workforce, attrition. The number one thing that this, poll suggested is that, our 550 participants today want to hear more about how to make their buildings more efficient, through maintenance of their building automation system. So it's very appropriate for me to turn things over to Dr. Katipamula from the Pacific Northwest National Laboratory. And I'm going to let him explain more about his role in the function of the Pacific Northwest National Laboratory and talk about efficient buildings.
Okay, good morning, everybody. This is Srinivas Katipamula. As you heard, I'm a staff scientist from Pacific Northwest National Lab. For those of you who are not familiar with Pacific Northwest National Lab, it's one of the multidisciplinary labs that primarily we work for Department of Energy, but we also do a lot of work for other federal, state, and even private sector. Our work encompasses from fundamental science to applied. Obviously, I work in the area where it's mostly applied research, and we have about 4,000 plus people working at the lab, and in the buildings area, there are probably about 300 or 350 of them. For those of you who are not familiar with where it's located, it's in Richland, Washington, which is about 300 or 200 miles southeast of Seattle. So jumping into my presentation, we have been working with improving the efficiency of commercial buildings for a long time. About 8 years ago, we had this opportunity to work with a project funded by state of Washington, where we developed a training for building operators of buildings, large commercial buildings that have building automation system. And that's what we call retuning training. And it's kind of unique because it has both a classroom portion of it and also a field portion of it. And to define what retuning is, it's basically a systematic process to identify and then correct the building operational problems that lead to excess energy use. So the unique aspect of this training, in addition to having the field component, is gathering the data, the trend data from the building automation system, analyzing that through a tool that we've developed that is openly available. And it essentially tells you clues of what's wrong with the building. So, primarily we look at operational aspects. We don't look at capital investments. We don't, although we do touch a little bit of that, but our primary focus is operational improvement. Because we use the trend data, we are able to identify things that normally you don't see when you walk a building. So in that sense, we can identify a lot of the things that a typical retrocommissioning agent would not be able to identify when they're doing a walk down. And typically we collect 2 to 4 weeks of data to do that analysis. And so to compare our retuning approach to retrocommissioning, you can consider this as a retrocommissioning light, although primarily focused on operational aspects and leveraging the data from the building automation system. So I'm going to cover the rest, what I'm going to cover in the rest of my presentation in about 10 minutes is a meta study. And what I mean by meta study is it's essentially a synthesis of 100 mini studies. So when we conduct a training in a building, we essentially have a test site where we collect the data and analyze the data and use that data in the classroom to teach. And then we also follow up the next day in the field test, right? So we have about 100 mini studies that we've done on 100 commercial buildings. So this essentially, in the next 10 minutes, I'll summarize those results. There are 3 different projects that actually contributed to this meta study. Initially, as I said, we started with a project funded by Washington State, and then Department of Energy, the Building Technologies Office picked it up, and then we actually did this across the nation, primarily working with large portfolio building managers. And then more recently, we are working with GSA to actually not only to teach them, but also to implement some of the findings. So that combination of all of these ended up being about 100 buildings. So, what does the universe of retuning measure consist of? There we have about 144 measures, and they're categorized variously into these groups that we show. For example, on air handlers, we have 38 different measures. And these are not problems associated with the equipment, but these are the problems that either relate to our inability to control that equipment properly or to optimize or better manage that control sequences. For example, on air handlers, an example measure would be a lack of a static pressure reset or a lack of a supply temperature reset, things like that. And there is a much bigger presentation, about 60 slides, that covers all of that, and it defines all of this in detail. So if someone is interested, at the end of the presentation, there's a link for that you can download that. So these are basically the various measures. They're categorized as air handler associated zones, schedules, lighting related, hot water envelope, and domestic hot water and chilled water. So, and then if you look at that 100 buildings that we have, obviously, we are biased towards larger buildings because those are the buildings that have building automation systems. So typically 100,000 square feet and higher. And then in terms of vintage, we're pretty much, uniform across, going back from 1950 to most current. There's some variation between the decades that we show there, but they're essentially uniform there. However, as I said, we are biased in the sense that a large fraction of that, half of our 100 buildings are office buildings, and the rest of them are what you see there. And then since these are bigger buildings, they're multi-story buildings. They're 6 to 10 story buildings are about half of our sample. So, and then if you look at the, when we go to these buildings and we analyze the trends, we create these various measures that can be implemented. And if you look at that distribution of those measures, they're fairly uniform across age, across size, and across building type. You can't really see those graphs on the right, but if you, in the bigger presentation, when you look at it, the blue bars that stand out are air handlers. So they're kind of, uniform across all of these three different categories. And then in the next few slides, I'll basically go to the conclusion of what we ended up with that study. There are a lot of things that happen in between, and I'm not covering that. And for those for those details, you can always go back to the study that I referred to earlier. So, and all of the buildings that we touched, the 100 buildings, have multiple measures that you can implement that would result in savings. And some of the common ones are listed here, and the next slide actually shows graphically some of the same information. So lack of schedules, and you'll be surprised, how many buildings still run equipment during unoccupied period when you're not supposed to. And so these are the things that you generally don't detect if you're, if you're walking the building during daytime, you don't see that. But since you have the trend data, you can actually look at that over a period of time, both during weekday, unoccupied weekday, and also on weekends when the buildings are typically unoccupied. And you'll be surprised in how many buildings still have those problems. And also night setbacks, that's also a common theme. Lack of static pressure reset. That's one of the big savings that you can achieve if you reset your static pressure based on your zone conditions, and you hardly see that type of control sequence implemented in the building automation systems. So here's a list of top 15 or whatever that we found in terms of prevalence. So for example, the top one there, no discharge temperature reset. About 65% of the buildings that we analyzed had no discharge pressure or discharge temperature reset. And same thing, about 50 or 65% or 63% of the buildings don't have any static pressure reset. So there are a number of things. There are also a lack of proper schedules. That's almost 50% of the building. And then all the way down, if you go look at, no hot water differential pressure reset at 15%. So, a number of things. And if, this is obviously across the 100 buildings, right? So each of the building, if you look at it, typically we find anywhere from 10, 15 measures to maybe 30, 40 measures in each building. And if you implement or if you correct those things, you can get significant savings out of that. So the big question people ask us is, what's the savings when we do something like this, right? So, we don't have measured savings on all 100 buildings that we have analyzed, but we have savings on a fraction of the buildings, about 30 or 40 buildings that we touched, right? So this slide actually summarizes those results. So, in all of the buildings, all the 30 buildings that we have measured savings from, if you look at, for example, air handlers, right, only half of the measures that were identified were implemented. So other half were not implemented. Even under those conditions, if you look at the savings, they range from 2% to 26%. With a median, that is 50% of the buildings that where we had measured savings showed at least 15% or more of energy savings. So if you look at the cost-wise, normalized cost savings, they're anywhere from 0 to 60 cents a square feet, with a median about 12 cents a square feet. So that's pretty significant savings. And that considering that not all of the measures that are identified are implemented. If all of the measures were implemented, the savings would have been even greater. So to conclude, the lessons that we've learned over the past 8 years, touching these 100 buildings, all of the buildings, we touched, have many issues, and mostly relate to our inability to, control these buildings appropriately. All of these buildings have sophisticated building automation systems, yet we don't use the full capabilities of this building automation system to realize an optimal or near optimal even building operations. So trained building operations staff is the key, and if we train and empower them, you can see significant savings anywhere from as low of 5% to as high as 30%. I only say 20% because a lot of the times when you even know some of the problems, you really don't correct them. So the actual potential could be actually greater than 20%. So the problem is that you have to train them, you have to empower them, and even if they fail, encourage them to do the right thing. So in the long run, they succeed. Again, in the long run, talking about long run, we think automation is the key to ensure persistence and optimal building operation. What I mean by that is a lot of the things that you can identify through the process that we developed can be automatically corrected. For example, schedules, if there's an excursion of that, you can automatically correct those. And those are the kinds of things that you can implement that, removing the building operator from the loop. So we are working on the things of that nature. It's still in R&D stage, and we hope to see that implemented in buildings so that the building stock is fully or operated more efficiently than it is operated today. So, and that's the end of my presentation, so we'll continue on with the rest of the presentation.
All right, thank you, Dr. Katipamula. This is Juliet Pagliaro-Herman. Now, Buddy Saucier and I are going to talk about a couple of considerations that you can take on your own building automation systems to start to try and progress to achieve some of the energy savings that Dr. Katipamula was referring to in his meta-analysis. So the first thing we're going to talk about is 3 key maintenance activities that we really believe should be performed on every building automation system. And those activities are system verification, sensor calibration, and database backups. And so we're going to go through these in a little bit more detail so you get a sense of what we mean by these things and what value they bring and how they can impact energy, productivity, and occupant comfort in your facilities. So let's start with system verification. And this is really a thorough check of control sequences and points associated with a piece of equipment. And as you saw from Dr. Katipamula's research, each one of those systems had its own unique issues with regards to control systems. So it's really important to start to put those systems on a schedule, to start to review how are those things operating. Are they communicating? Are they responding appropriately? I had the privilege of working with Dr. Katipamula, and one of the most common things is, you think it's doing something, but when you actually go out into the field, you realize that damper is stuck, or it's, in one case, in one building, it was actually laying on the ground next to the piece of equipment the economizer actuator was. It was not even attached. So very important not only to check from a control programming standpoint, but actually to look at that end device and make sure it's responding appropriately.
Yeah, I'd like to call it stretching the building or exercising the building, Juliet, because you got a lot of things here like VAV boxes and terminal units that are very difficult to get to. And like you said, maybe in an air handle you can see an actuator sitting on the ground, but in a VAV box you're not going to go through a building of 300 VAV boxes. So there's other means using the BAS system to verify is it actually working properly with airflow and temperature and so on.
Yeah, I think that's a great point. With the new BAS technology available, there are a lot of tests and other things that can be run to ensure that those things are actually responding appropriately. The next bullet is really around that, are the sequences still appropriate for the way the building is being used today? And so again, that gets to a lot of what Dr. Katipamula is talking about. Do we have schedules? Do they still make sense given the operating hours of the building? Are there additional enhancements that we can add to the sequencing to get more out of the systems that are in the building? So a thorough review and making sure that A, that those things are implemented, and B, that someone hasn't overridden them or put them in manual mode. Because if you think it's working one way but someone's overridden the sequence, then suddenly you're not achieving the energy savings and you're not getting the persistence that you're expecting from that piece of equipment. So, and then finally, excessive alarms. This is a common problem, and I think Jim alluded to the sheer amount of data that's coming in, and alarms is one of those sources of data where it can be very overwhelming to the operator to try and weed out what's really a problem versus what's really just been threshold set too tight or other things. And so looking at those alarms, identifying which things are really problem areas that need to be addressed and which things we really need to adjust those thresholds in the system in order to make sure that we see the critical alarms, but we don't have so many alarms that we're just acknowledging them all and missing potential problems and energy wasters.
Yeah, we've seen a lot of customers, we want to use data, we want to verify with data, but sometimes we've gone way too far. And when you have your tolerances very tight, like you mentioned, Juliet, you can have a lot of alarms. It can be overbearing to an operator.
Yeah, absolutely. And again, these checks really need to be done on a routine basis because unlike, an equipment retrofit, once you make a change in an equipment retrofit, that equipment stays replaced. If you do something to change or enhance the control sequence, there's always opportunities for somebody to undo what you did. And so really, it makes a lot of sense to routinely go through these systems. The other thing is your building changes. The way you use the building changes. The space is may be different. The hours of operation may be different. So that's the other reason that it's really important to get these things on a regular schedule.
Yeah, we've seen that quite a bit, Juliet, as tenants change through a building floor to floor or site to site or occupancy to occupancy.
Great. So let's talk a little bit about why this is important. again, based on Dr. Katipamula's research and other research, most of the items found in retro-commissioning studies relate to operations and controls. And these tend to be the high, low effort, quick payback items that really can have an immediate impact on a building in terms of energy saving opportunities. The other thing, again, having the privilege of working with Dr. Katipamula for a little bit, often you kill two birds with one stone. So you're correcting an energy efficiency, but you're also doing something that improves the control of the environment. So either the ability for occupants to be comfortable or for that environment to be controlled in the way it needs to for a data center or manufacturing opportunity. And then finally, a lot of these issues can cause things like excessive cycling, which really cause wear and tear on the physical equipment itself. And so, by taking care of control issues, often you have a positive benefit to your mechanical equipment for running it efficiently. All right, let's talk now about calibrating sensors. And again, we talked a little bit about the amount of data that comes into a building and a reliance on decision-making that we've been placed on that data. So the thing is, if you have bad data coming in and you're integrating that data with other systems, you have the opportunity to make bad decisions because you don't realize that.
All about the accuracy.
Exactly. So the other thing is, studies have shown that sensor error is one of the top 5 causes of operational energy waste and also affects the comfort and ability to meet load. And 30% of the buildings in the PNNL study had issues with their sensors. So we'll talk a little bit more about calibration and what you should be thinking about. Critical control sensors, sensors that are actually involved in the sequence of operations for the equipment, you've got a list here on this slide, really need to be calibrated twice a year. Now, as new sensor technology evolves, we're seeing more self-calibrating sensors, and this reliance on manual calibration is reduced. But most buildings are older and don't have this newer technology, so you've really got to be thinking about this twice-a-year schedule. Other sensors, like zone sensors, they're less critical to the energy savings and less critical to the operation of the equipment itself, so they can really be calibrated once a year.
I think what we typically see in the field with our customers is that we, depending on the product or the occupancy, has a lot of determination on that strategy. So you think about a pharmaceutical clean room versus a hospital versus a commercial space, has a lot to do with building that strategy of how often you're going to calibrate your sensors there.
That's a great point, Buddy. And I think you wanted to talk a little bit about database backups.
Yeah, Juliet, the things that I find around database backups, I like to go right to the value, right out of the gate, because reducing costs and restoring a system. Usually when this happens, we've all at some point in our life have lost a PC and lost the hard drive, and it is very painful reconstructing and re-imaging that. And we've just seen it over and over with some of our clients where they haven't really built that strategy around, have a good strategy around database backup. Highly recommend, depending on the type of product, occupancy, type of customer, what you're doing, we'll have a lot of determination in this strategy. Is it backed up on site? You talk about the disaster recovery plans, things of that nature, may cause you to go off site, may cause you to have multiple layers of backup. Again, around the cybersecurity we were talking about plays a lot into this as well. But the key, what I like to consider the third key here is to have a really good, robust data backup plan.
Yeah, disaster recovery is really important. And, one of the things Renee mentioned at the beginning of the call is that minimizing risk is really something that we're seeing across the board as critical to our customers. So database backups plays right into that risk minimization strategy.
Absolutely.
So the other thing we'd like to talk to you about outside of those 3 key maintenance activities is some other ways that you can get some additional information, training, and help to enhance building operations. And again, there's 3 key services here. One is operator training and technical support. A second is remote monitoring. And a third is technology upgrades. So we'll go into those a little bit deeper. So we talked a lot about the challenges, right? People are seeing a lot of complexity in building automation systems, and we're losing skilled operators due to workforce attrition and other factors. And so operator training and technical support really help shore up some of those issues. So technical support, is often online access to a database that has troubleshooting and product information, and perhaps phone support as well from a national support center. So operators can get answers to questions quickly that will allow them to implement some of these strategies and get more out of their building automation system. The other thing is, on-site training really helps tailor a one-on-one experience with an operator paired up with an experienced controls expert to help them through that individual's specific problem and issues. And it's really an efficient use of time, because instead of having the operator sitting in the classroom, they're actually sitting in front of the system. They're doing training and they're problem solving around their system at the same time. So they get the benefit of both getting instruction from that trained expert as well as solving a specific problem in their building that they're having challenges with. Remote monitoring, again, we'll go right to the value. I mean, really to leverage the power of technology to connect these systems to a remote monitoring center that watches over them 24/7 really provides the peace of mind and, again, that risk minimization for downtime and system failures. And often these services are highly customizable, so you can set up exactly what things you'd like to have notifications on, who those notifications go to, even to have the provider do some first-level troubleshooting for you and pass that information on to your building staff. And this really helps, supplement your staff by notifying them of those critical issues that you've flagged, and potentially also providing some of that troubleshooting assistance to help them get them quickly resolved and onto the next thing in their day. Finally, we want to talk about upgrading building technology in the technology in the building automation system, and Chris alluded to this in the panel discussion as well. And there's really 2 key reasons. One, Chris touched on, is that IT and security enhancements really are ever evolving. And so in order to keep pace with those ever-changing standards and information that we have, upgrading and updating software has actually been identified as one of the 5 key security countermeasures recommended by the Department of Homeland Security's Control System Security Program. So keeping that system up to date is probably one of your best defenses. The other thing is, new technology really can improve productivity, environmental control, and energy efficiency. I just think about some of the things that have evolved over the last couple of years in terms of self-tuning control loops and state-based control, which actually prevents you from doing things like simultaneous heating and cooling, which is a huge energy waster. Those things have all come about over the last couple of years, and if you've got an older vintage building automation system, you may not be taking advantage of some of those newer technologies. The other thing that's really evolved, and again, Chris alluded to this in the panel discussion, is that the user experience has really evolved very rapidly, and it's in part due to the different expectations that people have as they interact in social media and other internet-based systems. And so a couple of examples of this. One is having a device-agnostic, mobile-optimized system. So a system that actually, it's the same system regardless of if you access it from your computer at your desk or on your tablet or on your iPhone. And it really helps streamline that operator training because they only have to learn one version of the software. And also when you think about your building operators, I mean, how often are they actually sitting at a desk, right? They're walking around the building, they're solving problems, and being able to pull that information up on a mobile device is really, really helpful. Chris, I don't know if you have anything to add or elaborate.
Yeah, and we're exploiting new technologies like HTML5, which can provide a very rich user experience without having any type of client-side software plugin like Java or Silverlight or Flash. So by exploiting technologies that exist in the marketplace that are standard like HTML5, we can provide a user experience that's mobile or fixed with the same experience.
That's excellent. And then the second piece is really, having a more intuitive user interface. And I think Apple's really been at the forefront of this, making the device so easy to use that you really don't even need any training at all. And so a lot of it has to do with how do we arrange this information in a way that's very intuitive for users to access and do the tasks that they need to do. So examples of this include space-based navigation, where instead of navigating by systems or controllers, you're actually looking at a zone or at a building and all of the equipment that serves that zone or that building. And it really helps the operator identify some of these problems that Dr. Katipamula's research showed. The other thing is, creating these intuitive reports that create daily punch lists for problem areas in the building, or, intuitively displaying relationships between pieces of equipment also really streamline the troubleshooting and help that operator get to the root of the problem. Chris, do you have anything to add on that one as well?
Yes, we spent thousands of user research hours in the field talking to users of building automation systems, and they want an easy-to-learn, simple interface that can allow them to be instantly successful with what they need to do, with finding information, learning about their system, and then taking action. So things like using search to find a space, building in relationships so that when they have a hot call or a cold call in a space, they know that the system has built into it the known relationships between that space, the terminal unit equipment that's serving that space, the air handling equipment that's serving that terminal unit, and then the central plant that's serving that air handler. All of that information is at the tip of the user's fingers, and he doesn't have to memorize those relationships or keep a cheat sheet of those relationships. The system has that information built into it, and it makes them more productive.
Excellent. Thanks, Chris. Well, now I'm going to hand things back to Scott for another poll.
Thanks, Juliet. Our second question for the audience is, what is your current approach to BAS maintenance? All or nearly all performed by internal staff, split between internal staff and an external vendor, or completely outsourced? Again, we'll give the audience about 30 seconds to respond, and we'll take a quick look at the results. Okay, by a large margin, the leading response was split between internal staff and an external vendor, followed by completely outsourced, and then all or nearly all performed by internal staff. Okay, now I'd like to turn things back over to Buddy, who will be talking to us about maintenance strategy.
I tell you what, Scott, that's not very surprising. That's what we're seeing more and more customers do today. They're supplementing their workforce with outside service provider assistance. So let's talk a little bit about what it takes at a high level to build a strategy. And you got to have a plan. I mean, you got to have a plan with anything you do. And one of the first things you need to do is really assess and evaluate the capacity of your team. Do they have the bandwidth? Next thing is the capability. Are they capable? Have they been trained? And that's another part of retention. We talked a lot about workforce attrition, training, having a happy workplace, employee engagement, all goes into those things. But when you do reach out and you look for a service provider, to help supplement your staff, these are some of the things that you need to look for when you're evaluating those partners here. Do they process the three key maintenance items that we've been talking about here on this webinar today? And are they flexible enough? You know, can they tailor a plan and a strategy to your building or your complex? And more importantly, are they able to work with your staff and be part of your staff? And can they provide that supplemental training, whether it's BAS? Can they provide the experience and technology around controls as well as mechanical? And importantly, which probably should have started off with, is safety. You know, you want to make sure that a service provider has a very good safety record. And also, don't be hesitant to question, do they have a customer loyalty program? Do they periodically poll and survey their customers to gain feedback so that they can have improvement? And then as we wrap this up, you know, in creating the plan, you know, I like to start with the last bullet here, and that's, it talks about documentation and tracking and managing, but it's all about communications. It's about having those touch points periodically, and again, it goes back to the importance of the product or the occupancy. You know, how often those touch points take place, how often do you document it, the strategy around it, the frequency is all determined around that product and occupancy. And that's how you work with an external partner or in-house setup as well. I have to say, Renee, we talked about a lot of stuff today: risk, opportunity, energy efficiency, a lot of opportunity with BAS systems, Internet of Things. I think it was a great webinar.
Yeah, I do too, and I appreciate, you know, all of our guests and panel for joining us. And maybe I could turn things back to Scott to see if we have any questions from our audience.
We do. We're running short on time, so we'll probably only have time to get to a couple of them. So we'll just jump right in. First question, what is the definition of Internet of Things?
That's a great question. This is Juliet. You know, Internet of Things is really embedding sensors into physical objects and then linking them through Internet protocols so that data can be taken from those physical objects and aggregated and either used for machine-to-machine communications and actions, or to be analyzed and provided to someone who's going to consume it to make decisions. Chris, do you have anything to add to that definition?
I think that's a good definition. I think building automation systems have actually been at the forefront of the Internet of Things. Building automation systems network different components together. Oftentimes their components are connected to the Internet for remote access. And now with the Internet of Things, we'll see more and more other devices that will be capable of connecting into a building automation system, providing more data and more opportunities for data to be shared and for relationships to be understood, synergies to be created, and action to be taken.
I think, too, you'll start to see more and more relationships form between larger companies and service providers and to gain more access to data, more and more data.
Mm-hmm.
All right, next we have, it's more of a comment than a question, but I was hoping maybe you could comment on it. Keeping all equipment functional on site is such a challenge that this all seems very idealistic, not so realistic. Would any of you like to comment on that?
Yeah, I'll take that, Scott. I think first I agree with the comment. I think, you know, that's the beauty of having more information, more data as we move forward, because, I mean, truly, a lot of the buildings that we're in have an awful lot of deferred maintenance. And so customers come to us all the time and say, geez, help me prioritize, you know, my deferred maintenance. And so, you know, data helps us, you know, and helps business owners, building owners, make decisions that are economic, you know, or related to their business otherwise, to rack and stack that deferred maintenance. I think, you know, what else comes to mind for me here is, you're right, we can't, not all things are created equal. We can't do everything. The building's not going to be perfect all the time. So I think it goes back to a little bit about what Juliet and Buddy were talking about in terms of developing a maintenance strategy, if you will, you know, where you use a combination of predictive and reactive maintenance based on the risk that you're willing to tolerate, based on criticality of different areas of your building, and you're developing that kind of proactive maintenance approach. So anything else, Scott? I know we're running out of time.
Yes, we have time to get to a couple more here. What are some of the non-traditional items that you are now connecting to the BAS that you did not do in the past?
I see we're starting to connect to different enterprise applications like work order management systems. We're seeing, I guess, a more frequency of, so we say we can connect to lighting and fire and security systems, which we have that capability, but we're seeing the frequency of that increase more and more, especially with new construction type projects. I don't know if you've seen any other types of interconnection.
Yeah, sometimes with business systems where there's stores of data, those stores of data can be brought in and for example, using HR information or badging information to identify occupancy and control the building that way as well.
And we're seeing some of the edge devices, but especially, I guess, energy meters become more smarter. So in the past, maybe an analog meter that was tied into a controller is now a smart device in and of itself and is networked into the building automation system and provides more information than just energy consumption or demand. Maybe it's providing power factor or other information that would be useful for your energy management functions.
Okay, our next question, where can we get the PNNL 144 BRT measures?
So there'll be an opportunity at the end of this webinar to request some additional information on Dr. Katipamula's study, and we'll follow up with that information so you can access the full study and also the rest of his research.
And then we'll wrap up. We had a question about where people can find this webinar later to show others in their organization. This webinar will be archived on hpac.com for 1 year. It should be up within the next week, and everyone who's on this call will be notified via email when that archive is available. I'm afraid that's all the time that we have today. On behalf of HPAC Engineering Magazine, I'd like to thank our sponsor, Johnson Controls, for making this webinar possible, all of our presenters for sharing their considerable expertise, and all of you for attending. Take care.